Chapter 10. And the earth was without form and void. The earth a differentiated planet. The earth is layered. Let's look at some of the reasons why that fact is important. The core. The earth has a metallic core composed of solid inner core surrounded by a liquid exterior. This is important because it is believed that the movement of liquid metal in the core is the source of the Earth's magnetic field. The magnetic field could be considered Earth's perimeter defense mechanism against the bombardment of charged solar particles from the sun. Life on land could not exist without the protection of the magnetic field. The magnetic field is where the Van Allen radiation belts are found. These Van Allen belts are formed when charged solar particles come in contact with the magnetic field lines and are directed toward either the north or south poles. The particles are forced along the field lines high above the planet until they come in contact with the Earth's atmosphere and harmlessly burn up, creating the spectacular northern and southern lights. The mantle. Surrounding the core is an area of lesser density called the mantle. The mantle is mainly composed of a mineral called olivine, which is a silicate with iron. It is believed there are convection currents in the upper area of the mantle just below the crust. These currents combined with gravity drive the process known as plate tectonics, a process that will be explained later. What are convection currents? If you have ever seen water boil during a boil, you have witnessed convection currents in action. The water at the top of the pot is the hottest because it is next to the heat source. The hot water rises and then cools when it comes in contact with the air. Because cooler water is denser than hot water, it sinks to the bottom of the pot to be reheated. The same thing happens inside the earth. Magma, the heated material in the upper mantle, rises until it comes in contact with the crust. The magma moves laterally along the bottom of the crust, creating a dragging action against the crust and cooling the magma in the process. This dragging action with gravity helps drive plate tectonics and pull the crust back into the upper mantle to be reheated. The crust rides on top of the denser asthenosphere, the top layer of the mantle. The crust itself is differentiated. The densest crustal material is on the ocean floor and is mainly composed of basalt. The continents are composed primarily of granite, which is lighter than basalt. Floating on top of the oceanic and continental crust is a hydrosphere composed of water, and covering the entire planet is the atmosphere composed of gases. Plate tectonics. Understanding the process of plate tectonics is necessary to help know how old the Earth is and why this planet looks the way it does. Earth's crust is divided into a series of plate tectonics. These plates are dynamic. They move. Plates in the process of colliding are called convergent. Those sliding past each other are called passive, and plates moving away from each other are called divergent. Often a plate has both continental and oceanic crust, with the continental crust riding on top of the oceanic crust like a giant gab. Let's look at a description of 3 different plate boundaries to help us understand why the Earth appears the way it does. Divergent plate boundary. The Mid-Atlantic Ridge is a good example of a divergent plate boundary. Here, hot magma pushes up through the crust, creating a new oceanic crust. In the process, the magma shoves the American plates west and the African and Eurasian plates east. If spreading centers push plates apart, then somewhere, plates must be colliding. The crust is deformed at convergent boundaries where plates collide and mountains are built. Let's say there are 2 convergent plates. One is made of heavy oceanic crust, basalts, and the other lighter continental crust, granites. What would happen if these 2 plates collided? Because the granitic crust is lighter, it will ride over the top of the heavy oceanic crust, and with the help of gravity, the oceanic crust will dive beneath the lighter continental crust and push down into the asthenosphere. This is called subduction. But the salted crust will start to melt on its way down into the asthenosphere. The partially molten material will rise because it is lighter than the surrounding rock. If the magma reaches the surface, a volcano is formed. An example of this is the Ring of Fire, the group of volcanoes surrounding the Pacific Ocean. But if the magma doesn't reach the surface and gets trapped below it, it could solidify and become a granitic intrusion like the Sierra Nevada mountains. And once granitic material is created, it is too light to ever be subducted. What would happen at a convergent plate boundary where two plates of light material collide? Because neither is heavy enough to be subducted, so that they would pile up and form a large mountain range. This is what happened when the Indian and Eurasian plates collided. They piled up, forming the highest mountains in the world, the magnificent Himalayas. Plate tectonics. So why explain all this about plate tectonics? I describe the process of plate tectonics for three reasons. First, to explain why the surface of the Earth appears the way it does. Second, to show that the oldest rocks would be found on the continents. And third, to give the reader a rough idea of how old this planet really is. The very oldest continental rocks discovered are in Canada and have been radiometrically dated to be about 4.28 billion years old. The age of the Earth, however, is estimated to be older. By using dated rocks from the Moon, because Moon rocks are not subject to erosion and tectonic forces like those on Earth, scientists estimate the Earth is about 4.5 billion years old. And the Earth was, after it was formed, was empty and desolate. Abraham's description of the primordial Earth was accurate. The surface would have been a hot, seething, and desolate planet, too hot to permit water to condensate. But as the Earth cooled, eventually clouds formed, it began to rain. Rain filled the lowlands. It formed puddles, oceans, lakes, and streams, and prepared the Earth for life.